GATE 2015 set 3 EC question number 29. A vector field D equal to 2 rho square arrow plus Z AZ exists inside a cylindrical region enclosed by the surfaces rho equal to 1, Z equal to 0 and Z equal to 5. Let S be the surface bounding the cylindrical region. The surface integral of this field on S, that is the closed loop integral over the surface, that is the surface integral d dot ds, is given by, for NPTEL reference you can refer to lecture The Divergence Theorem Gauss's Theorem of the NPTEL course Electromagnetism by Professor Nirmal Ganguly, Department of Physics, IISER Bhopal. Coming to the useful data, Divergence theorem states that the surface integral of a vector field E over the surface is same as the volume integral of the divergence of that vector field. Now the divergence of the vector field is given by, for cylindrical coordinates, as 1 by rho d rho e rho divided by d rho plus 1 by rho d e phi by d phi plus d ez by dz, where E vector is given by E rho a rho cap plus E phi a phi cap plus Ez az cap, where E rho, E phi and Ez are the rho, phi and z components in cylindrical coordinates of the vector field E. Now coming to the solution, it is already given that the vector field is to be found, that is the surface integral of the vector field d dot ds is to be determined, and enclosed by the surfaces rho equal to 1, z equal to 0, z equal to 5. Applying divergence theorem, this is equal to volume integral divergence of d dot ds dot dv, where v is the volume, Now this volume is to be determined within rho ranging from 0 to 1, z from 0 to 5. I think you can imagine that like this: rho 0 to 1, z 0 to 5, z 0 to 5, that is this, and phi all 0 to 2 pi. So now given this, the elemental volume dV for a cylindrical system is given by rho d rho, because if this is rho, we go d rho d phi, and this is dz. So rho d phi, so this is a rectangle like thing, so we get this area, that is rho d phi, this into this d rho into dz. This is the elemental volume into dz. This is the elemental volume. So elemental volume is like this: you have rho, then you have d rho, then you have d phi, then you have dz. So this is like this. This is the elemental volume. D is given as 2 rho square a rho cap plus z az cap. These are the rho and z components. Now then the divergence of D is to be determined, where divergence of D is 1 by rho d rho d rho d rho plus 1 by rho d phi component is the phi component, and then z component with respect to dz. Now hence divergence of d is coming out as 6 rho plus 1. Okay, so now the volume integral is given by divergence of d dv. Now we know the rho is varying from 0 to 1, the phi is varying from 0 to 2 pi, and z is varying from 0 to 5. So the divergence of d is coming out as 6 rho plus 1, and the elemental volume we already have determined that it is rho d phi dz. So normal scalar multiplication, and you have this coming. So this is 6 rho square plus rho integrated with d rho 0 to 1. Then you have phi, and then you have z 0 to 2 pi, and then you have z 0 to 5, which is equal to 2 rho cube plus rho square by 2 0 to 1, then d phi dz, which are from 0 to 2 pi, that is for phi, and 0 to 5 for z. Now you have, after integrating these are independent integrations, and you integrate and you put the results here. So 5 by 2 into 2 pi into 5, which is 25 pi. So since the value of this volume integration comes out 25 pi, hence this surface integration d dot ds also is same as this, which is also 25 pi. Now the answer is coming out as 78.539. So the answer is 78.539. Thank you.